Hey, math friends. So our learning target today, and I actually only have it stated on the top. I don't have it right on the screen. Whoops, I forgot about that. I can problem solve probability word problems. So that's going to be our learning target for today. And you can see it on the top of the screen. Sorry about that. So just a bunch of different varieties of calculating experimental probabilities, theoretical probabilities, make predictions, things like that. So you absolutely want a calculator in our work as we go. All right, let's take a look at this first question. Kathy randomly pulls one block from the box. So first thing I'm going to do is summarize kind of what I have in there. So it looks like I have 5 black blocks. That's hard to say. 2 gray boxes and 3 white boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Want to verify that that adds to 10 boxes. Sweet. All right, so let's find the probability of each event down below. So what is the probability that I get black? So we have 5 black out of 10, which just reduces to 1/2 or 0.5. So you have a 50% chance that if you were to reach in without looking, that you would draw out a black box. So what's the probability that it would be white? The probability is that we have 3 out of 10. Again, reaching in without looking. Of course, if you're looking, you'd get a 100% chance that you draw a white. So you have to assume that you're not looking. You could type that in your calculator, but I'm pretty good when I have a denominator of 10. So we would end up with 0.3 or 0.30, which is 30%. Of course, there's always that placeholder that's sitting there that you learned in elementary school, that there's always those placeholders. So 30% chance that you would draw a white. So pretty easy math there with a denominator of 10. All right, moving on to the next problem. Steve made 24 out of 36 three-pointers. Wow, that's pretty good. Out of, so there's our of, right? There's our of. What is the experimental probability that Steve will make a three-point shot during tonight's basketball game? So really, we're just talking about what's his probability. So we're going to reduce this looking at any factor that would come out of those. So I could cut those both in half. If we think of factors, division by 2, top and bottom. I could divide by 2 again, which would give me 6/9. And then if we look at 6 and 9, we're looking for, is there any common factors that we could divide out of each of those? And when we do that, you can see that we can divide by 3 out of each of those, which results in 2/3. So we're just saying that 24/36 reduces to 2/3. Just an equivalency of probabilities there. Nothing really changing, just we know that he has a 2 out of 3 chance of making that happen. You could always turn that into a percentage as well, but that would probably be the easiest approach, is just reduce it. What's the chance? Nothing special happening there. All right, next problem. Lisa randomly pulled one marble out of a sack. What is the probability that the marble is not white? So we're looking for the probability of not white. So I'm probably going to just figure out the total first, and then I'm going to figure out how many that are not white. So 1, 2, 3, 4, 5. Might do that in a different color. 1, 2, try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Total of 15. How many are not white out of 15? So I'm going to highlight the whites, those ones, those 5, which means 10 are not white if 5 are white. So we're just reducing 10/15. If this had asked a question about what percent, then we would be calculating percent, but it's just asking us to reduce, simplest form. So I'm going to divide top and bottom both by 5, which results in 2/3. So again, same answer as before. You have a 2 out of 3 chance that when you reach in there, you get a marble that is not white. Cool. Let's take a look at the next problem. I might actually skip that one. Let's do this one. There are 30 jelly beans in the bag, so out of 30. Not sure what I'm going to do with that. Of these, 5 are red, 6 are yellow, 5 are black, 3 are orange, 4 are green, 7 are purple. So that would be our 30 marbles. Leona selects 1 jelly bean from the bag. What is the probability that it will be black? So if we take a look at that, we would say, well, we can see that we have 5 black marbles out of 30. So that equates to lots of different things. So we would say 5 we could divide down, as we've talked about. Just looking for probability here. So 5 divided by 30 gives me the decimal of 0.16 repeating, so about 16%. And it's asking what is the probability that it will be black. So which one is the closest probability? I guess this is the only one that is correct. 5 doesn't make sense because 5 is the number of black marbles. It's not the probability. It's not 0.2, it's 0.16. And it's not 30%, it's 16%. So the only answer that would be correct there is that you have a 5 out of 30 chance of drawing a black marble. Or jelly bean, rather. Jelly bean. Yuck, I hate black jelly beans. All right. So 9 balls are numbered 1 through 9. Let's check it out. So we have a situation where we have, I probably shouldn't be using the highlighter because it's so big, but all right, there's our 9 balls. What is the probability that we will draw a ball without looking that has an even number on it? All right, let's see. So if we take a look at the evens, that would be 2, 4, 6, and 8 are the evens. So you have a 4 out of 9 chance. None of those are in fraction form. So I'm going to convert, divide. So when I do that, I go 4 divided by 9 is 0.44, which is looking like 44% chance. And so it looks like our answer then would be A, that you have a 44% chance that you would draw an even number out of the 9. Cool. All right, more probability coming our way. I'm going to look for a couple independent, dependent, and see if I can grab something there. Let's do this one. If you roll a fair number cube, they just mean a dice, like a fair dice where all 6 sides are the same. You've probably all seen dice before where they're a little lopsided, where one side is like shaped different than the other. With that, we can't use that. How many times would you expect to roll a 2? So let's first talk about probability of rolling 2. We'll use that to make predictions. So theoretical probability of rolling a 2. If you think about rolling a dice, we call these the outcomes. These are the things that are possible when you roll a dice one time. So thinking about a dice, when we roll it, these are the things that could happen. So rolling a 2 would be only one of the sides or one of the outcomes out of 6. So the question is, if you were to roll 42 times using the theoretical probability, what do we predict would happen instead of out of 6 times out of 42 times? How many times do we expect to roll the number 2? Just using good math prediction. And because this is a nice mental math type of question, you could just multiply by 7 here, top and bottom. So we would predict that 7 out of the 42 times you would roll the number 2 using probability. So your answer then would be C. That's a prediction question using theoretical probability. All right, each night a dinner table is randomly set with 5 red forks. That's 5. 3 blue forks, 7 green forks. So that's 15 forks, right? If you eat at this table 30 nights, how many times would you expect to get a red fork? So if we talk about the probability of red, we're talking 5 out of 15 total forks. So instead of 15, let's change that to 30. How many times would we predict that we would get a red fork? So if you look at just following pattern here, we multiply by 2, multiply by 2. You can always take cross products. We would predict that you would get 10 red forks. So there's just another good example on that. And the last problem is going to be an independent, dependent question. We're going to use this question, but we're going to just change it a little bit. So Ruby has 4 red hats and 6 blue hats. So 4 red hats. Probably should have done it in red, but that's okay. And 6 blue hats. Cool. What is the probability that she will draw a red hat and then a blue hat, noting that once the red hat comes out of the bag, it does not get replaced. So she wears the red hat, it gets all sweaty and gross, she decides to throw it away. Okay, so we have 4 reds and we have 6 blues. Cool. So what's the probability that she first draws a red, she wears it, it's gross, she throws it away, she reaches back in without looking and gets a blue. So we would have dependent events here, so the denominator is going to change, and we're going to multiply the 2 events together. So in the first draw, what's the probability she gets red? She has a 4 out of 10 chance that she gets red. She takes a red out. She wears it. It's gone. One of the reds is gone, which means now she has a denominator of only 9 hats left. How many of those hats are blue? Still has 6 blue in the bag. We multiply since it's a probability of dependent events, so the denominator changed. So if we multiply the tops, lost the problem here. So we multiply the tops, we get 24 over 90. We could reduce that as a fraction, or we can type in our calculator to get the percent. So 24 divided by 90. So I'm simply just dividing down, which gives me 26.7% or 27%. That was a repeating decimal of 6 there. So 26.6666, and I rounded it to, I guess I'll just leave it a 6. 26.6% chance that you would draw a red and then a blue. Our learning target today is I can problem solve probability word problems. Have a glorious night.